So following on from the previous video, I will now give you an example of a reflection transformation. So this red graph here is given by this function here. In this video, we're going to look at this transformation. What happens when we apply this transformation to this function here? So currently the red line here is given by this function here. So when you draw a table here, hang on. So this function here, when x equals 0, so you put 0 into this x here and into this x here, the whole thing then becomes -2. And when x equals 1, you put 1 into here and into here, then the whole thing here becomes 2. Or if you put -3 into this thing here, -3 here into here, the whole thing here becomes -2. So this second row here represents this function here. Now we want to investigate what happens when you apply this transformation to this function. Okay, so let's look at let's start randomly at 1. When x equals 1. Okay, you got to ask yourself what goes into this slot here. Well, when you put 1 into here, it's you doing this, f of -1. So what goes in this slot here would be you stealing f of -1. Well, -1 is here, f of -1 is here, so it's really you stealing this point and moving it across here. So what that means graphically means what that means graphically is this. So f of 1 is here at the moment. Our old function is here. Now we've got to ask ourselves, what will our new function look like? What will this function here look like? So you could ask, well, when x equals 1 here, well, hang on. When x equals, you got to ask yourself, what goes in here? So you put this 1 into here. So it's you stealing f of -1. So f of -1 is this thing here, so it gets moved across here. So what goes here is -4. So what that means when you come to look at your graph is you're asking yourself, what goes along this line? Well, what goes along this line would be me getting this value here. Okay, so f so f of -1 would be here. So what goes along here would be me getting this point and moving it across here. Basically, it's you stealing this point and moving it to here. Okay, it's you getting this point and moving it to here. Okay, so this point here is the point of our new function. Now ask yourself, what goes along the what goes along this line here when x equals 2? Now, what you're asking yourself, what goes along here? What goes in here when x equals 2? Well, you got to put this 2 into here. So that's you working out f of -2. So f of -2 is here. F of -2 is here. So it's you stealing this point and moving it across here. So it should be -4 over here as well. So what I'm saying is, what goes along here would be you stealing f of -2. So it's really you, f of -2 is here. So it's you moving this point to here. Okay, so our new point will be here. So far our new function will look something like this, because this bit here. Okay, so it's really a reflection. So negative when it's 3 here, you are getting the value of -3. So it's this point being moved across here. So our new point will be here. So it's you joining up. Hang on, let me just tidy this bit up. So it will look something like this. Okay, and what goes negative? What goes at 4 would be -4. Well, -4 is up here. F of -4 is here. So you've got to move that all the way to here. Okay, so this is our new point here. So and then when it comes to 0, you see 0. When you put 0, f of 0 is f of 0 is -2. But then when you put f of -0 is still, well, along here is still the same. It's just at this point here. Okay, and then when it's on the negative side, f of negative 1 is you stealing this point here. Because, okay, let's look at this bit here. Negative 1. So on here, what goes in here would be, well, you got to put this negative 1 into this thing here. So that's like you doing f of negative 1. So that's really the same as f of 1. So what goes in here would be you stealing, well, 1 is here, f of 1 is here. F of 1 would go into here. So this bit here would be 2. So we are stealing this point and putting it into here. So what's going on here is when you're trying to do negative 1 here, you are actually stealing f of positive 1. So 1 is here, f of 1 is here, so that gets moved, this one gets moved to over here. So our new point, hang on, let me just tidy this up. Our new point here, so what goes along the negative 1 would be you stealing f of positive 1. So it's this point being moved across to here. Okay, so it will be here. So our new function would look something like this. Okay, so our new function would look like this. Okay, so this is our new function here. You see, along here, what goes along x equals 1 would be you stealing negative 1. So this point here gets moved to here. Well, when it's 2, what goes along the 2 here is you stealing f of negative 2. So this point here gets moved to here. Now, when it's at 3, it's you stealing f of negative 3. F of negative 3 is here, so it's you moving it across here. That's why you get this reflection along the y equals along the y-axis here. Okay, so given a function. But by the way, what is the equation for this blue line here? What is the equation for this blue graph? Well, our old function is this. If you want to know the equation of the blue line, it would be you doing this. It would be you putting negative x into here, and then negative x into here. So it will look like this. Hang on. Negative x, okay, squared. So that's this taken care of. Plus 3 times negative x here, and then minus 2. Okay, so now what you've got here is really negative x squared. So that's like negative x times negative x. So that's positive x squared. This whole thing here is positive x squared. Okay, so positive x squared, and this one here, 3 times x, that's normal, that will be 3x. But then you've got this negative here, so that would be negative 3 here, and then this is negative 2. So the equation of this blue line here is given by this. So starting from this, you can actually come up with an equation for the reflection of this. Okay, so the equation of the blue line is given by this here. Okay.